Hi and welcome to this video. In this one, we are going to talk about JavaScript data types and variable declaration. So hit that subscribe button and let's get started. Now, originally, when I thought of this playlist or this tutorial series, I didn't think of adding specific lectures or lessons for JavaScript data types all the way to Rust. So then I thought, okay, if I'm starting to teach programming languages in the context of challenges, it would be better if you have a little bit of experience, like some exposure to what are the different ways a programming language saves some kind of data. And I thought that would be like a very good entry point for, especially for people who don't have any prior knowledge of any programming language. So the idea of this video and the next 4 videos is to show you the different data types in JavaScript first, then TypeScript, and then we're going to jump into Python. From there, we're going to go to Go, and then we're going to jump into Rust. So in these first 5, in these 5 videos, we are going to dedicate one video for one language. But once we get started with our challenges, it's not going to be one video, one challenge, one language. It's going to be one video, one challenge, 5 languages. So we are going to solve one challenge in one video for all 5 languages, and we're going to compare their implementation, their approach, and how each one implements these data types. This is just some introductory lessons. So if you know these, you can just skip these and wait until the next videos are uploaded. Or you might be watching this at some time where the videos are already uploaded, so you can just jump directly into the first challenge. Now, let's get into this lesson. So in here, we are going to talk about JavaScript data types. JavaScript itself is a high-level programming language, which is also dynamic. So the only 2 things that you need to take away from JavaScript. It's high-level. It means we don't concern ourselves with small little things like memory management. So that makes JavaScript easier to learn. That's why it's easy to learn. And then it's a dynamic. It means we don't type annotate our variables. So whenever you declare a variable, you can later on change its type. That's why it's called dynamic. So in JavaScript, we have a lot of different data types. And the reason that we use data types is because whenever we're working with anything in our computer, we are dealing with some kind of data. Now, that data might have different formats. When it comes to higher level languages like JavaScript, the data types they tend to be less in number than in mid-level languages like Rust and Go, because they want more control, so they have more data types. The first data type that I'm going to talk about is going to be string. For example, a name, let's say Jane Doe. Now this is a string. Now I want to save this somewhere so I can use it later. The way we store a string in JavaScript is we write it on the right hand side, then there is going to be this equality sign. Then where do you want to store it? So you need to give it an identifier or a pointer. So whenever you call that pointer or you ask it, the pointer is going to give you, or the identifier is going to give you this name, which is Jane Doe. And this could be customer name. Now, the string is Jane Doe. That's normal English. But the name or the identifier is customer. I didn't provide any spaces and then name. That's a convention. So each language is going to have its own convention. This identifier naming, this is a convention in JavaScript, and the reason for this is so we know what is the name of something and then what is the date. And it is called camel case, and that's for a very good reason. If you take a look at the first word, it says customer, but starting from the second word, we have the first letter capital. So that's why it's called camel case. And then after this, we need some kind of, in JavaScript, we need some kind of a keyword to initialize this variable. And I'm going to use let for now, but then we are going to talk about, by the end of this video, you will know what let is and why we use that. Now here we go. This is our very first thing that we stored inside our file a-data-types.js. And now how can I see this? I need to basically put it somewhere. So I could log it to the console, and I'm just gonna grab. Now, if I were to log it, should I grab the string or should I grab the pointer or identifier? We should grab the identifier. Now, wherever we use this identifier, it's gonna point to this value, to the string. Let's save that. Let's say note A, run it, and it says Jane Doe. So this is string, and we're gonna go like this forward. So what I'm gonna do with this is gonna be something in JS, and then we're gonna change this value as we move forward. So I don't have to copy paste. I don't have to create so many console logs. Now, the first one, something in JS, that was a string. This is called a string. The next one, we could say something in JS. Now, what if you want to store a number? How do you store that? You're just going to say 12 or 13 or whatever. Now, there is an error. The reason for that is once we initialized a variable, we cannot initialize it again. And the way we initialize a variable is using some kind of a keyword. Because now here it says let, we should remove let again because we're not initializing this, we're changing its value. So let's get rid of let. Let's save that. Now if I were to run this file, now it says 12. So this is the second data type. It is called a number. After that, we have another data type, which is called a Boolean. Now, the reason that we would use a Boolean would be for some logical operations. Does it happen or it doesn't happen? Is something true or is something false? That is going to be Boolean. Boolean has two values. It could either be true or it could be false. It can't be anything else. Now, with string, it could be all the strings in the world. With number, it could be all the numbers, but with Boolean, it could be one of the two. It's either this or this. And now if I were to run this, this is going to give us false in the console. Next up, we have undefined. Now, undefined is a data type that allows us to create some kind of a variable that doesn't have a value, that we have not actually assigned a value for. So if I say something JS, we're going to say undefined. Now, you're not going to intentionally write undefined. This is going to be presented to you in the form of an error or a bug in your application where you're trying to get some data, but then that data doesn't exist. You're going to see an example of that by the end of this video, in a real world example of that here as well. So if I were to say undefined, we're just going to go ahead and run this, and it's going to say undefined right here. Now, if you want to create a variable, but you don't know the value for something, and you intentionally want to show to other developers that you don't know the value for it, you're going to basically initialize it to null. So this is the difference between null and undefined. Null is intentional. You say, okay, I don't know the value for this, but I still want to create the variable. I still want to create the pointer. At a future time, I might add a value for this. But right now, I don't know what that is. So that's the intentional. But undefined is not intentional. It's going to be something that is going to be thrown at you. After this, we have something else that was introduced in 2020, which is called a big int. Big int basically allows you to create larger numbers. Now, it is something beyond this value. So if you grab 2, raise it to the power of 53 minus 1, this is the limit of this number. So let me just cut it, put it right here. This is the limit. So this is the largest number that you can create with a number data type in JavaScript. But if you want to have larger number than this, then you could go ahead and you could create, you should use big int, and you could create a number like that. So it could be something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then denoting this, that this is a big int, you should just put in an n there. Now there is another operator in JavaScript that is going to give us the type of a variable, and that is called the type of operator. Now if I were to run our code, we can see the type of the latest number that we created here, the type of that is big int, big integer. That's why it's called big integer. Now, so far, everything we have talked about here, all of these are something called primitive data types. Let me type that, primitive data types. Now, in JavaScript, we have something that is called a non-primitive data type, non-primitive data or DT data types. Now, when it comes to non-primitive data types, they're a little bit more advanced. They're a little bit more evolved than primitive, as the name suggests. The major difference between primitive and non-primitive data types is that primitive data types, they store by value. Non-primitive, they store by reference. I'm just going to write here reference. And I'm just going to write here value. Now, what does that mean actually? Now, if we take a look at our primitive data type, we can see the latest value that we gave to this is our big int. All right. So this is the latest value of this something in JS. Now, what I'm going to do is I'm going to say, okay, I have a big number and I'm going to set it to this something in JS. I have this big number. Let me initialize this variable as well. So whatever goes inside the set something in JS is stored inside of this big number. And then I get this big number and I say, okay, let me grab this big number and I'm going to say, okay, this is my big number. So essentially what I did was I changed the value of this big number. So since this is a primitive data type, it doesn't change the value of something in JS because this variable right here, this is stored by value. And whenever we put it inside this big number, a copy of this is put right here. A copy of it, not the original. We never change the original. So let's see that in action. Let me create another log. Let's say big number. And in front of it, I'm going to say big number. And I'm going to create another log and I'm going to say big int. And this is going to be something in JS. Now, these are going to be two different variables. Save that, let's run the file. There we go. So big number is 1, 2, 3, 4, 5, 6. Big int is this number. But this is different when we talk about non-primitive data types, because non-primitive data types, they store by reference. So whenever you change the reference, the data is going to change. What is an example of a non-primitive? Let's say you want to define the correct characteristics of something. That thing could be anything. It could be a person, it could be an object, it could be a house, it could be a car, anything you want. All right, let's say I want to define let's say I want to get a pet, right? And let's say I want it to be a German Shepherd. So that's the kind of the pet that I want to get. So I want to get a dog. I want to get a specific breed. Perhaps I want to get like I have some age in mind. Now, you cannot do this kind of data storing using primitive types because there is one thing that I have in mind, that's a pet, a dog, and then there is several things that are attached to it. So all of them, they go together. But with primitive types, it's all separated. Like no two things are connected together. So let's say I want to get a dog. I'm going to say my pet. And this pet is going to have a name. The name, let's say I'm going to name it George. George was actually my very first dog name. So I'm going to say name is going to be George. The breed is going to be, let's say, German Shepherd. I'm not sure how to pronounce shepherd. to, I'm not, maybe there is an age there or not, I'm not sure on it. So age could be, let's say I want to get a puppy. So I don't like 6 months. All right. So here we have this pet and it has 3 different kind of data attached to it. Now you can see we have this error because we need to, now this is the data that I want to represent using JavaScript. The issue is that this is not JavaScript syntax. So we need to write it in the JavaScript syntax. The first thing that you need to do is you need to select all of that and you need to put it inside curly braces. This is what it's called. You can see curly braces. There we go. We have curly braces right there. And then inside the curly braces, you have 2 things. You have a key and then you have a value for that key. So I have a name and then in front of the name, I have a value. So in front of the key, you put in a colon and after the value, you put a comma. And then you have this key. You put in a colon in front of it and then a comma after the value. And then a colon in front of this. And the last one doesn't need. And as soon as you save it, it is going to be rearranged. Now, why did I do all of this? This is because that's the JavaScript syntax or grammar where you need to put a period or comma or that sort of thing. So each programming language has its own separate grammar, like German or English, or the grammar is different. There are going to be some things which are universal, like periods, commas, but where you put them might change depending on the language. And it goes the same way for here as well. Now, why did I use this? Because I have several different information in the form of a key and a value, and then I want to store all of that inside a variable. Now, you need to initialize this variable as well. Now, let me zoom it out a little bit. It's way too zoomed in. Here, if I were to run this file again, oh, we're not printing anything. So I need to say my pet, save that, let's run it. And this is what we get. We get the object. Now, when it comes to the object's members or these key value pairs. So each of these in JavaScript is called a key value pair. And in total, or both of them, you just call them a member. A member has a name and a member has a value. And if you just hit dot, you're going to see the name for that member. And you can select that. So if I say, okay, give me the age of the dog, you need to save the file and you need to run it again. And it's going to say 6 months. So this is how you provide data. Now, this was like a lot of complex interrelated data. But what if you have just a list of something? You have a list of numbers or a list of grocery items. You could create them using JavaScript as well. But for that, you need to have some other kind of data structure. And that is called an array. So these are going to be repeated throughout TypeScript, Python, Go, and Rust in different forms. But essentially, they do the same thing. They store data in different formats. So let's say I want to store numbers 1, 2, 3, 4, 5, 6. Now, you can see as soon as I do this, and if I initialize this, it doesn't work. There is like 5 errors right there. So I can't use the primitive number type. So there should be another way. If I were to grab all of this and put in an object, there is still an error because objects, they need their syntax. They need the colon, they need the comma, but I don't want an object. I don't have a key and a value. I just have a value. That's it. Or in the language of arrays, I just have an item. So the way you would go about this is you would select it and you would put in square brackets. And then after each number, you need to provide the comma. There we go. And as soon as you save it, it's going to fix the order. Now here, I'm just going to say numbers. Save that. And as soon as I print it here, this is going to show us the numbers. Now, I could select each of these numbers based on the index. Let's say I want to select the third number. So I'm going to put in the index for the third number, and it's going to give me 3 because that is the third number. And the reason that I put in 2 is because indexes or indices in JavaScript, they start from 0. So the first number, it has an index of 0. The second number has an index of 1. And the third number has an index of 2. That's how they work in JavaScript. Now, I did talk about the way primitive types are different than non-primitive types. We have the reference. Now, what did I mean by the reference? So let me comment out this array. Let's say my pet here, all right? Now, this is the pet that I want to get. Now, you know what an array is. Probably I should have explained that first and then jumped into the objects. But anyway, so here I have my pet. Now, let's say I want to adopt another pet. I'm going to say let my pet 2. And then I pass in this pet, all right? But I wanted to have a different breed, right? So I'm going to say my pet 2, and I want to change some breed from this. For example, I want to grab the breed, or maybe I want to get 2 German Shepherds. I'm not too familiar with I am familiar, like there is Pit Bull, there is Doberman, there is Rottweiler. It's just, I'm not sure how to write them. Like their pronunciation is a little bit different. Pit Bull is okay, so I could grab the breed. And let's say I want to change the breed for the second one. Now, I wanted to have, for example, the same name and the same age, but I want to change the breed. So it's going to be Pit Bull. I hope I'm correct. Maybe there is just one T. See? So I'm going to save this. Now let's take a look at our pet. So I'm going to say pet 1, and then this is going to be pet 2. For pet 1, we have that, and for pet 2, we have that. Let's save this. Let's clear this. Now, what should we see? We should see one object that says name George, breed German Shepherd, age 6 months, and another object that should say name George, breed Pit Bull, and then age 6 months. So 2 objects, almost the same, but just the breed is going to be different, right? That should be what we see. But there we go. That's the problem. See, take a look at that here. Let's zoom this in. Now, the name is the same because we didn't change the name. We have both of the names are the same. But then the ages are also the same. And then we have our pet 1, pet 2. But why did the breed change? Why did it change? Because we stored a reference to our object. We didn't store the actual object inside memory. We stored a reference. And what is the reference to this object? So we have this object. What is the reference to it? It's my pet. And I put this reference, I copy it inside here. But in fact, I'm not copying it. I am giving the reference. Think of it like this. You have a remote control. Non-primitive types are like remote control for a TV. So what you do is, so you turn on the TV, for example, you go to Disney Plus or YouTube or whatever. Let's say you go to Prime. You want to watch a movie. And then you're watching it, the remote is like in your hand, and then someone takes it from your hand and then they change the channel. So what happens here? Is the remote copied, or the same remote goes to someone else? The same pointer goes to someone else. That's a non-primitive data type. So you change the pointer, you don't copy it. But in primitive data types, you copy. So in primitive, the thing would be like if someone takes the remote out of your hand in some other universe, the remote would actually be copied. And then you would still have your own remote with your own Prime Video, and then someone else, when they turn on or they want to change, they would create another TV and they would watch something else in there. So, and then if someone else does it, that would be a third time, a third remote and a third TV. So that's a primitive data type. But the non-primitive data types, once we put the reference inside something else, this my pet no longer has the reference. The reference is inside my pet 2. This my pet no longer has the remote control. This one does. So whatever the second person changes the channel, the TV is going to show that, even for the original person or for the original pet. So that's the simplest I could explain. So these are the differences between primitive data types and non-primitive data types. And this is how you go about these. Let me comment these one out. Let's save this. The final thing that I want to talk about is variable declaration. So we saw one way to declare a variable that was using let. This is considered a new, but it's like almost 10 years old. It's not new. It's the latest way to create a variable. So creating a variable, you have three keywords. We talked about let, so you have const, you have let, and then you have the old one, which is var. The difference is the way they create variables, in which scope they create variable. So when you get into programming, you're going to hear scope a lot. Scope is where a variable's value is accessible. So any file has a scope. I have this a-datatypes.js. This object that I've defined here, this is only available inside this file. If I were to create another file here, this object would not be accessible in that object. And the scope of a file is called a global scope. If you define a function, the scope of a function, the body of a function is called a function scope. If you define anything inside a block, in JavaScript, if you have like simple this to curly braces, opening and closing, this is called a block. So this is also another scope, and it is called a block scope. So there is a lot more, but for now, you just need to keep in mind we have general, or the global, which is actually called the global scope. You have the function scope, and then you have the block scope. So we have these three scopes. When it comes to var is actually either global scope, var, or it is function scope, var here as well. But we don't see var when we go to our block scope. We don't see that. Let and const are block scope, which means they are function scope as well as general scope, global scope. So this is the difference. What does scope mean? Scope is where you can access a variable's value. Now, you can't access the variable's value inside a block scope. It wouldn't make sense for var. But these let and const, they're confined to the scope of this block. I'm going to give you some examples. What do I mean by that? So if I grab this var and if I create another variable, I can say I'm going to say some name. Let's set it to John, whatever. So this is var. Now, how do we access this? We can say some name. And I'm going to say some name var. So just to know that it is var. It is accessible inside the global scope. So when it comes to the, why am I doing that? So when it comes to the global scope, we can access all variables. It doesn't matter how we initialize them. So this part is done. If it is using var, it should work. If it is, I'm going to say John var. This is going to be John let. And this is going to be John const. So let's define it using let. And then let's define it using const. But then remember, every word's first letter should be capital. So let's capital that as well. And now let me copy this 2 more times. This is let. And this is const. And now as soon as I save my file, there we go. We got var, let, and const. That's okay. So this is called the global scope. Let me bring down the comment. There we go. So the global scope, you have understood what that is. That part is done. Let me copy this and I'm going to comment that one out. Let's talk about the function scope. So we have function scope. Now, to be able to define a function, we would just say function. It could be some name func. And this is the syntax. So this keyword is something you need to provide in JavaScript. If you define a function like this is arbitrary, the name of the function, but these parentheses and these are required to declare a function normally. All right. Now in here, I'm going to put all of these, but I'm going to get out the console logs and I'm going to put it right here. I'm going to save this. Now you can see these are a little bit grayed out because we're not using them. And I'm going to call the function. Now, whenever you create a function, you need to call it because functions are not going to do anything until they're called. So I'm going to say some name func. And then when you call the function, you need to grab its name and put it in the parentheses. Why? Because in your file, when you're programming, you're going to have more than one function. So you need to first pass in the reference, and then this is going to execute that function for us. Very good. Let's save this. Let's run this file again. And now we can see we have a bunch of errors. Why? Because these three, as I said right here, I should have cut this comment, put it right here. I said they're function scope. So a scope is where a variable's value is accessible. They are function scope. When I say function scope, that means these values are only available within the function. When we said, okay, they're global scope, it means they're available inside the global scope, anywhere inside the global, anywhere inside the file. But when you define it inside a function, they're only available inside the function, not outside of it. So where are we accessing them? We're accessing them outside. Now, if I were to cut these, put it inside the function, and now if I were to save this, run it again, now you can see they're available because they are function scope. Now, let's take a look at the latest example, and this is going to show you the difference between all these three. So block, as I said, this is a block. Let me copy this. Let's comment out all of this. Now, whenever you comment out the code, it's not going to be shown anymore. Let's put all three there. Let's cut this, put it outside. Now, if you take a look at this, immediately you're going to see the difference. Here we have the var variable. You can see the pointer or the identifier is not grayed out, which means it's available outside the block. But for let and for const, it is grayed out, which means let and const are block scope. They're not like var, which is not block scope. var is not block scope because you can access its value outside the block. Let's run this code, save that. We still get a bunch of errors, but take a look at our errors. What did we get first? We got John var, and then we said, okay, some name let, that threw an error. Because as I said, you're going to see an example at the beginning of this video. I told you you're going to see an example of an undefined and it's going to be thrown at you. And here is undefined right here. It says reference error. I cannot reference that. I cannot find the reference for it. And it says some name let is not defined. See, it is being thrown as an error for you. And that's it. So this is available. These two are not available. None of them. So if I were to comment that one out, run this file again, we are going to still see the same error even for const. Some name const is not available. All right. So now you know the differences between let, const, and var. We call them like that. We say let and const and var. And we don't use var because of these issues. That it does not block scope. We just use let and const. Now you might be asking, okay, what is the difference between let and const? Both seem to be global scope, both seem to be function scope, and both of them are block scope. So what is the difference? The difference is that const is a constant where you create a constant. But with let, so here, let's go to the top. Take a look at this. How did I initialize this variable? I said let. It wouldn't work with const because whenever you're working with const, it is only going to give you an immutable binding. And in programming, an immutable binding is just a word for the association between a variable name and the value that it holds. When I say the binding of const is immutable, what I mean is you cannot make the variable name point to a different value. But that doesn't happen when we talk about let. So as soon as I change this let to const, save this, let me comment that one out, Let's grab our variable. So I've said it, I've stated that I've basically changed it to const, something in JS. Let's save that. Let me clear this. Let's run our file. We get an error. Why do we get an error? Right here. Now, see, the errors are different. In the previous error, where we talked about var and let and const, it said a reference error because it couldn't find the reference or the identifier for the value. But here, the error is different. It says type error. You need to keep these errors in mind as well. These are very important. Type error, assignment to constant variable. Because we said, okay, constant variable is the string Jane Doe, and then we change it to 12 and then subsequently to a big int. That doesn't work in const. So once you give it an immutable binding, you cannot change the reference to something else. So when we talk about primitive data types and const, you are essentially having the same reference point to a different value. That doesn't work. So this is how const works when we talk about primitive data types. But it works a little bit differently when we talk about non-primitive data types. So to be able to show that to you, let me get rid of all these errors. Let's say clear. So in non-primitive data types, let's say this is our object, right? Let's convert this to const. Now, what was the result? Let me first just revert it back to let. Let's bring back our console logs and let's run it. We can see by putting the reference inside mypet2, we essentially changed our original object. So we changed the value in some way. But even if I change this to const, it doesn't throw an error because there we go. You can see it still says breed pitbull, breed pitbull. It's like we didn't do anything. The reason for this is these values are there. These variables store their values by reference, not by the actual copying of the value. So when I pass the reference of my pet from my pet to my pet2, this const is now thinking, okay, this object is stored inside my pet2 because we changed the reference. We didn't change the actual value. The reference itself changed the value. We didn't change the value. All right. So this works. But if you were to go ahead and say, okay, my pet should be equal to an empty object, meepet. It doesn't work because now you're assigning something else to something that has been declared using const. There we go. So here you can see it says type error, assignment to constant variable. You're reassigning that. But here we're passing the reference to something else, and then we change some part within that reference. We don't change the actual reference, right? We don't make it point to some other kind of data. It is the same data. So this is how it works when it comes to const. Usually when you go to React and create projects with React, or you create vanilla projects with JavaScript, you're going to use const for the majority of parts, and you're going to change it to let whenever there is an error, whenever you're reassigning this const. You're giving it a different value, you're going to see this kind of an error, and then you're going to change it to let. And that's my suggestion for you as well. Just go ahead, use const everywhere, because it gives you a little bit safety, especially in vanilla JavaScript. And then once it throws an error, you can just always convert it to a let, like this. So you're just going to say let. Clear, run it, and there we go. We have breed pitbull, because we cleared the object and then we added one breed in there. That is going to be it. I believe this is it for this lesson. It went a little bit longer than expected, but no matter. We did talk about a lot of things. JavaScript is done. Next up, we're going to talk about TypeScript. And after that, we're going to go with Python. Go and Rust are going to be longer than these videos. They're going to be really long, because there is just a lot to talk about when it comes to data types. Go and Rust are mid-level programming languages, which are technically systems programming. They directly communicate with the memory and CPU. So it's very important to understand all of the jargon and data types surrounding them. And I'm going to make sure that I take my time to explain how all of this works. But for now, that's it. See you in the next one.